Hello, everyone. This is my name is Matt Danner. I'm the owner and founder of a company called Monolith Forensics, and I'll be hosting this webinar today and basically talking about some programming skills and incident response and digital forensics. A little bit about me and the company. If you're not aware of us already, we sell and create software for managing your digital forensics team and labs. So if you're working in a digital forensics lab or e-discovery team or incident response team, our product Monolith is something you potentially use to kind of manage your casework, manage evidence, track notes, collaborate together on projects, that sort of thing. So what I'll be doing in this webinar today is we're going to talk a little bit about programming in the context of forensics. And a lot of what I'm going to be talking about and sharing are just basically resources and tools that that we use here at Monolith to work on our programming skills, work on just resources that we use when we're building or working in Monolith. For some background, my background in forensics is that's what I started my career in. I've been working as a forensics consultant for over 10 years. I've done all kinds of casework, everything from criminal cases all the way up through civil litigation and into incident response work. So I've got a career's worth of experience there. Plus, I'm also the lead engineer at our company for Monolith itself, where I have myself, and then we have two engineers on staff that work on Monolith. So there's three of us total. So we internally use a ton of resources and do a lot of stuff related to writing code and building applications, especially related to Monolith. So I want to kind of take what I've learned there and share it here. I've also used, in my career as a forensic examiner, forensic consultant, expert, I've used, code writing and scripting my entire career for various things. So part of what I'm going to share too is just here's some stuff. If you're not used to writing code or know kind of where to start or how it's going to apply to forensics, that's kind of what this webinar is about. I'm just going to share resources and tools and different things that I've used over the years to kind of become more well in tune with writing code. Primarily, and what I'm going to do here is I'm doing kind of an interesting way of presenting this, where I'm not going to present a PowerPoint or anything like that. It's kind of boring. What I actually have, you should already see it. What I'm sharing my screen where you can see my Chrome web browser, and I'm just using Chrome's tab system and grouping system to kind of group all the resources together that we're going to cover. And I'm just going to kind of go through those one at a time and kind of go through the process here. So if you have questions, there is a Q&A section and a chat. So as I'm presenting, if you have questions, just pop them in, and Megan will let me know if there's any that come up, and I'll try to answer them as we go along. But other than that, please enjoy, and let me know if you have any questions or have anything interesting to say. So the first thing I'll start with is why, if you're in digital forensics, if you're working for law enforcement, or if you're working for a consulting firm, or if you're working in incident response, why do you care about, why do you care about writing code? Why does it matter to you? Why is it important? How is it going to help you succeed in a forensics career? The first caveat I'll say is that you don't need to know how to code to have a successful career in DFIR, but I can tell you that it's one easy way to quickly separate yourself from other professionals in the field. The fact is, most people in our field are not comfortable with writing code, or they're not very familiar with it, or don't find it to be a very interesting thing to do. So that means that it becomes kind of a rare skill in our industry. So usually, the rarer a skill is, the fewer the people that do it, the more valuable it becomes. So that right there is a reason alone to kind of start picking up some coding skills and figuring out how to write code and script out problems, things like that. The other important thing about writing code that's probably not super obvious until you start writing code is that when you write code, whether it's in Python or Node.js or any programming language, it forces you to have a better understanding of how computing systems work. So by default, when you write scripts or you write code, you have to understand how memory works. You have to understand how a computer processes information. If you're using, scripting to parse forensic artifacts or data or databases, you suddenly have to understand how the computer interacts with different data structures and how it handles and manages data that it's parsing and accessing. So because of that, it gives you an intimate understanding of how a computer is actually doing doing things and processing information under the hood. So it starts to peel away some of the abstract layers of computing. So most digital forensic experts, when they get in this field, or analysts when they get in the field, they kind of you go through training, you go through whatever training you want to go through. You go through IASIS, or you go to SANS, or you go to vendor-based training like Cellebrite or Magnet, or whoever's providing training, and you get an understanding of what artifacts exist and what tools there are to help you look at those artifacts. But you don't really get a very good understanding of why do those artifacts even exist in the first place? How does the computer or the operating system generate those artifacts? How does the operating system read and do things with those artifacts? Like, why are they there in the first place? How are timestamps generated? Things like that are kind of still a mystery because we don't really cover that stuff in training a lot. But when you get into programming, suddenly these are all concepts that you kind of have to know in order to effectively write code. You need to understand how the operating system is going to read the file system. You need to understand how does the file system read directories and read file information. When you start learning about NTFS and the MFT and things like that, and you start writing code or scripts in Python to that work on a file system, you suddenly see a lot of those MFT concepts come into play. Or you see this different file metadata that you can pull based on different programming languages that you use, or different scripts or different libraries that you use. So when you start to learn to code, and you start learning to, parse out files or extract artifacts or interact with an operating system, all of these things that you kind of learned in an abstract way through forensic training become much more granular, and you get a much more intimate understanding of how computing systems work. The other reason and probably the most important reason to learn how to write code is because if you're in a team or an environment where you know how to write code, you can basically solve your own problems. One of the biggest challenges that we face today as analysts is that, especially if you're very reliant on the software that you use, like if you're very extremely reliant on Axiom or Cellebrite or any of the number of tools that you're using, those are the two big ones nowadays. But even for me, my favorite tool is Xways, and even Xways, I have problems with it from time to time. The issues we run into with these tools is they're not always capable of parsing everything. You're kind of relying on the engineering teams of these various vendors to be up to date with parsing everything that's possible, or parsing all the information out of an artifact, or parsing an artifact that exists. Sometimes they prioritize based on resources what to engineer resources around. So sometimes Cellebrite and Axiom just don't parse everything. There's also open source tools out there too that have the same problem, where that's why a lot of times in forensics you hear everybody say, well, you need more than one tool because you need to try to overlap the deficiencies of each tool, right? But you still run into situations where there isn't an off-the-shelf solution to a problem that you have. It could be something like, a common example is if you're in law enforcement, you may do search warrant returns for different third-party services or social media companies, and they provide you a dump of data that's really hard to go through. It doesn't seem to have any particular standard format. It's not in a nice database or anything. So now you have this massive data from a social media company that is hard to look through, and you can't just easily provide it to an investigator to review. So I know a lot of investigators and analysts that will write scripts around these different search warrant returns to try to convert them to an easier to review format, whether that be a database or some kind of Excel file that makes the data a little bit easier to review. So there's problems like that. And you also have things like, various artifacts that you can extract from a computer that maybe Axiom or Xways or Cellebrite doesn't parse. So then you need to maybe build your own solution to parse it, because your choices are either your current tool parses it or you don't review the data. So those are your current choices now. If you don't know how to write code or know how to script anything, your choices are basically wait for an update to come through. But if you know how to write simple Python or some pretty straightforward scripts, you can just write your own solution to quickly get to the answers that you want. Or at the very least, understand the data to a point where you can maybe manually review it. So just to recap, those are kind of the two biggest things that I always tell people about when learning how to write code. First is going to be It's just going to improve your overall understanding of computing systems and how they work. It's also going to improve your understanding of how your forensic tools work. And then it's also going to just give you a third option when you're looking through data or trying to, parse or extract information or metadata out of data types that your forensic tools don't currently support. So having said that, excuse me, we'll hop into some of the resources that I compiled for this presentation. Right now, you're just looking at our website. So if you're in need of something like a case management for your forensics team or a place to kind of manage your analysis, check out our website, sign up for a trial, and we'll get you set up and see if it's something that could work for you. To get started, what I'll talk about is kind of the various platforms that, if you're not used to writing code, there's a lot of places you can start. There's a billion different programming languages that you can use. The most common that most people use in the forensics industry is going to be Python. Most of you are probably already familiar with Python, but basically Python is a good all-around language to do just about anything you want. It's called an interpreted language, which means it's not code that gets compiled. It doesn't compile. I mean, you can compile it into an executable, but it's not really meant for that. What it means by interpreted is it just means that you write a script in plain English and you have a Python runtime that effectively runs that Python code as is without requiring compilation. So for example, if you write C++ code, before you can run that C++ code, it has to be compiled first into what we call machine code, which that just means it's an extra step that you have to go through. Development takes a little bit longer. Creating C++ packages that other people can use takes a little bit longer. But C++ and C, those are much more complicated languages that I wouldn't recommend starting with. That's a very low-level programming. I would highly recommend you start with Python. Python's a great place to start. It has tons of documentation, tons of libraries, tons of training available, that sort of thing. An alternative that we use a lot at Monolith is something called Node.js. What this is basically JavaScript. If you're not familiar with JavaScript, JavaScript is a programming language that runs in web browsers. So whenever you interact with a website or a web app and you see like drop downs or interactivity on websites, that's being run by JavaScript. What Node.js is, though, is that it takes JavaScript and it gives you something that you can run similar to Python. So if you wanted to write a one-page script to do something in JavaScript as opposed to Python, you can use Node.js to do that. Node.js is just an installed system that gives you what's called the JavaScript runtime that it's capable of executing code that you write in JavaScript. So again, it has a package manager similar to Python, where there's tons of libraries, tons of support for Node.js, tons of tutorials and documentation. You can find just about as much detail and information on Node.js as you can about Python. And it's just another alternative if you're not, if you want to do something with, other than Python, Node.js is a good alternative to that. Last thing I'm going to introduce you to is something called Electron. Electron.js is what this is, it's a JavaScript-based application platform. So if you get really good at writing code and you want to start looking into building applications that you can share with other users that have a user interface, Electron is a really good option for that. There's a ton of options out there, but I find Electron is the easiest and the more straightforward version of it, where basically what Electron effectively is, it's like a wrapper for a browser. So it's effectively sort of like its own browser, but you can like run code inside of it and you can deploy code that you want inside of it so you can build your own applications with it. So just to recap, Python, Node.js, and Electron. These are three really good, solid platforms to get started with. And Python has its own UI libraries and stuff like that. If you start learning Node.js, Electron.js, pairing Electron with it is a really good pairing. If you use Python, Python has some of its own UI packages, like tkinter is one of the bigger ones, but there's some other UI libraries that you can use with Python to build an actual user interface for your applications. Nowadays, for programming and learning to code, one of the great things about learning to code is that it's probably one of the most one of the most technically competent skill sets you can have out there that's technically advanced, that's also completely free to learn. So what that means is that if you think about engineering as a professional class or engineering as a professional or highly technical skill, this is one of those skills. It's one of the last skills really that exists where you don't really have to go to college. You don't have to go to specialized training. You can effectively, because of the way that the software development community works, almost all training resources and documentation about learning how to code is completely free and open. So that means that if you wanted to learn Python today or learn how to write in JavaScript or Node.js or really anything, the internet has unlimited resources and documentation and training for you to take that you can learn how to write or put anything together. And to give you an example, what we're looking at here, this is Google's documentation for interacting with their APIs using Python. And what we're looking at here is we're looking at just their API documentation. They have this section called quick starts. So you can look at this and just say, okay, I want to write, and this is specifically Google Drive. So let's say you wanted to write your own scripts to collect Google Drive files or get metadata from Google Drive files that are in a Google account. Well, you can do that programmatically. You can do that in Python. You can do it in JavaScript, Node.js, in Java. They have also something here for Go, which is another program, which is Google's internal programming language that they created years ago. And it gives you these quick starts where it even gives you a pre-made Python script just to connect to their Google Drive API service. And where this is really important and this is really interesting is when you start, as we move forward into the future, more and more forensics is going to be happening in the cloud. What that means is like most of the data that we're going to collect and analyze is going to be coming from some kind of cloud resource. So what that means is that the forensic tools that you use, you may have an off-the-shelf tool that's capable of collecting this stuff on its own. But like I mentioned earlier, you're depending on the engineers of that company to build a system that collects all the data that's possible and is capable of displaying that data to you in whatever UI that they're using. And sometimes they just don't. Sometimes they don't collect all the data. Sometimes they don't collect all the metadata. Sometimes it could be that at the time the tool was initially built, certain types of metadata weren't available, but now there's metadata available now. And so this is just another way to sort of get to the resources that you want. And for example, if you could also be looking at a situation where an off-the-shelf forensic tool may cost thousands and thousands of dollars, but you may look at something like, well, I just need a simple script to help pull metadata from Google Drive files. And if you have a background in scripting in Python or Node.js or something, it might take you a few hours to write a script to collect the data that you need. And that's a script that you can use forever. And you may have just saved yourself, thousands of dollars in software resources. So there's a financial component to this too, where you can potentially engineer your own solutions to these things instead of relying on paying for third-party tools. But I wanted to show you this because Google does a great job of documenting their APIs and how to use them. They give you several examples to use, and not to mention these are things that people have written countless tutorials about on how to interact with them. So whenever I'm training or working with new coders, this is actually a place where I tell them to start. Is I tell them to start with Python and start with just interacting with Google's APIs, because they have a lot of this stuff scripted out for you as an example. It's easy to just kind of take this code that they have and just modify it a little bit and just add on to it to do different things that you want it to do. It's a really great first-time project to learn how to write code and interact with cloud-based APIs. Moving along here, there's also there's a website called w3schools.com, and it's just generally a good website that has like this is the Python tutorial that they have here, but they've got literally all kinds of tutorials and resources on learning how to do different programming things. Like they have a whole SQL system, they have stuff on JavaScript, they have stuff on HTML and CSS. You can see here Java, PHP, just all kinds of stuff here. That this is a great way to get started just learning basic concepts in different programming languages and in just programming concepts in general. I know this is one of the sites I started with years and years ago when I was learning how to write stuff. I think I used this to learn some basic SQL and JavaScript and that sort of thing. So this is just a great resource to use. Also, just in general, it's good to use the actual documentation for these different languages. So here we have the Node.js documentation on just how to use Node.js. So if I wanted to, for example, if I want to read the file system of something, let me see if I can find it here. Here we go. I can look up the file system documentation, and I can see here are all the different libraries that Node.js has. So we have FS here. So if I'm looking for something like, if I just want to read a file, we have fs.read. I could scan to that and just look at the actual, code for this. So we can see here it's giving you examples of how to read files from a file system and do a lot of different things. So there's training resources and things like that online, but sometimes it's just good to just start with the actual documentation. So I just read through, as you're writing code, read through the documentation of whatever library or programming language or whatever you're using, and just always have this available, because it's a good way to just go through. And sometimes tutorials can be a little bit verbose, and they can sometimes not cover a specific topic that you're looking for. So it's just good to get familiar with reading documentation of these different languages. And again, W3 Schools here has a Node.js tutorial system as well. So if you're interested in Node.js, you can come here, and it's a good place to get started. Also, don't discount things like, oftentimes when you're writing scripts, especially if you're doing mobile related stuff or or even computer stuff, so like web history and things like that, data like that's stored in SQLite databases. So again, just going to the SQLite documentation and reading through the different SQLite functions that are available and the SQLite syntax that's available. This can be really useful in just learning how to write code, especially when you're writing SQL. And lastly, YouTube is a huge place for programming tutorials. I mean, there's probably, I want to say maybe a quarter, probably 25% of the videos on YouTube at this point are programming tutorials on various topics. And so what I did here is I pulled up an example of just pulling up I just did Python Pydantic. Pydantic is a Python library that helps with data validation, which is a really common library used for data analysis and other like machine learning type things. And so this is like a Python search and then a subtopic of Python. And you can just see like all the videos that are coming up just on this one topic. So it's basically, YouTube is sort of like an endless archive of different types of tutorials and trainings in order to learning how to write code in Python or Node.js or C++ or really anything. So to recap here, with all of these resources, when I talk to a lot of people, they always talk about, should I go to a boot camp or should I go to, take some community college courses and pay money for a lot of training for this? And the real answer is no. Like, you don't need to. There's so much free online stuff. There's so much open source stuff. There's so much free stuff that you can just learn online by yourself that, to me, it really doesn't make any sense to pay for this kind of training. It makes more sense to just start digging in and start learning right away, rather than wasting your time and money going to some kind of training program to learn this stuff. Let's see. So next set of resources, I'm going to talk about just some basic utilities to get started with programming. One of the first things that I recommend is there's a utility called Visual Studio Code. This is a Microsoft product. It's a free, it's what we call a code editor and a code editing environment or code development environment. So what this really is just a place that you can write code, write scripts, and have it inside of a system that sort of manages all of your scripting files and manages your code. And it has utilities built in that help you kind of review the code that you're writing. So what's cool about VS Code is you can install it locally, which I have it installed locally. That's how I normally use it. But if you're really want to just try it out, you can also open it up in a browser. So this is it's just vscode.dev. Just go straight to it and it opens in a browser. And I've actually got a repository open right now that has some various SQLite scripts that I've written. And you can see what happens here is VS Code can recognize what kind of file it is. So it sees it's a .SQL. So it automatically applies appropriate syntax highlighting for you. So it's easier to read. So if this were a .js file or a .py file, VS Code is smart enough to know, oh, this is a Python file, so I need to apply Python syntax highlighting to it so that it's easier to code, easier to read, that sort of thing. Okay, I've got a Q&A. Do you have a favorite Python interpreter you can recommend? So I don't have a favorite interpreter necessarily, but whenever I write Python, I'm just using VS Code. I use VS Code to write Python, and then I use, in order to run it, I just use, this doesn't have it, but let me pull up the actual VS Code here. Hang on. So what you're seeing right now, this is the installed version of VS Code. And what's great about this is that we can open up what's called an integrated terminal right inside this system. So with this is effectively just I'm on Mac OS, I'm on a MacBook, so this is just effectively my Mac OS terminal. But normally what I do is I just use this, and whenever I write a script, I just write, I just run Python, to test that script. So I think I have Python 3 on this. Yeah, so whenever I write Python scripts, I'm just using this in the terminal window to actually run it. Let me make sure I'm switching over to the right thing here. I'm just switching back to my browser. Give me a second. Okay, so again, that's VS Code. This is pretty much something I personally can't live without. It's such a great utility. I also use VS Code for a lot of different forensic stuff too. There's times where I'll just open files in VS Code just to look at different things, and it's just generally a really great utility to use for a lot of different stuff. We also have so GitHub is another one. So GitHub is what GitHub is. It's a code, we call it code repository. So whenever you're writing code or scripts, GitHub is a great place to basically store the code that you're writing and also be able to manage changes to that code. So if you want to, if you write a script and then you want to make a change to it later, you can then write that change and then commit it to what we call a branch. And so you can branch off your code changes so that you can, you don't accidentally overwrite previous code that you've written. This is a really standard way. This is a little bit more advanced. So this usually comes after you started learning how to code. Once you actually get into the act of writing code that you share with others, using something like GitHub and with GitHub Desktop is a really good, something I highly recommend. Once you start writing more complex scripts or more complex applications, you really need some kind of version control system like this to make sure you don't kind of, basically screw yourself over when you're trying to make changes to your code or write features or write updates, that sort of thing. Another good utility is something called Postman. So Postman is really more for if you're writing scripts that interact with APIs like the Google Drive API. And what Postman does is it allows you to test how APIs work. So if you're trying to understand how the Google Drive API works, you can use Postman to test it. So to give you an example, I'll show you what, I have Postman pulled up live here. And I'll show you what it looks like. So what you're seeing here, this is Postman that I have installed on my system. And I've got our monolith API pulled up right now. And what I can do is I can pop in the API URL that I'm trying to use. I've provided like a simple parameter here, and I can click send. And what that does is it returns a record from our monolith API that we have running. So that if I want to interact, and this is very common because what ends up happening is when you write a script that interacts with cloud-based APIs, you need to have a way to kind of test that API and see what kind of data it returns. Because you can call this same HTTP, you can make the same HTTP call in Python, and you'll know that you're going to get this kind of data back in the response. So now that I know what this data looks like, I can go into Python, write my scripts, knowing that I'm going to get an object returned, a JSON object that looks like this, and then I can start parsing it in Python. So, and this is also good if you're writing your own APIs. You get to a point where you're writing, some kind of Python application that has an API service. You can use this to test your own APIs and kind of understand and make sure that the data looks the way that you want, that sort of thing. But this is a utility we use all the time. I use it in forensics. I use it at Monolith for programming. This is just a great tool and utility for doing, deep, app testing or web app testing or building, that sort of thing. Switch back over here. Okay. So that's it for utilities. Those are the basic ones. So just to recap, I'll cover one more. This one's a little bit more complicated too, but there's also something called Docker Hub. This gets into, this is a little bit more advanced, but when you start programming, eventually you're going to come across Docker. And what Docker is just a platform that allows you to kind of containerize your code and put your code inside of what we call a container. And that container then has kind of all the dependencies and everything that's needed to run whatever code you have. And it makes it a lot easier to share your code with others so they can run it without having to install like the exact right version of Python or the exact correct libraries that Python needs. It puts it all inside of like one container. And it's a lot more complicated than that. There's all kinds of stuff you can do with it, but basically this is a very, very powerful system. But what's great about this is that it has just has everything. So if you wanted to run, quickly run a MySQL database in a container, you can. You just download MySQL and run it locally in a container without a whole lot of fuss. This does have its own learning curve to it. So it's got, a fairly hefty learning curve, but once you get the basics down, it's really powerful. And you can just see, I searched MySQL and I've got all these other databases that are popping up. So something like Docker allows you to quickly and easily run something like a MySQL database really quickly. And you can even run multiple databases at once, in the same platform. And you can spin these up, drop them down. It's a very simple system. You can, if you get good at writing Python, you can package your Python scripts into a Docker container and share with other people that have Docker. And that way they don't have to install Python. They don't have to install any libraries or anything. They just need Docker and that's it. And they can run your Python Docker container to do whatever you want. So to give you an example, if you're familiar with log2timeline, there is a log2timeline Docker container. So this is and there's probably a few on here, but this is one of them. But basically this allows you to run, like if you want to run log2timeline on Windows, you can use Docker to do that. Because right now there isn't a log2timeline build for Windows. There's only a build for, I think, Mac OS and Linux. So if you wanted to run log2timeline on Windows, this is a great way to do it. You can just run the installed Docker or Docker desktop, and then just pull this image and then run it. And you can point it at one image, you can point it at some files and that sort of thing and generate a Plazo timeline. So this is a really, really powerful set of tools once you get to learn them. So now I'm going to move into some free resources, some free stuff. So if you head to our website at monolithforensics.com, we have a free tools section that you can go to. And we have a couple of free utilities here, some that are made by us, some that are not. So here we have our sort of classic Monolith Notes application, which is just a very simple note-taking application. We have this is a BitLocker key finder. This is just basically a script that runs on a system to find any possible BitLocker keys that may live on a system. DPAD, this is a utility that helps remove some formatted data from certain types of files. And then we also have Neptune. Neptune is an ICAC cyber tip processing engine. It just is there to help kind of go through cyber tips quickly. That's on our website. We also have Monolith. If you're a customer of Monolith, we have an API available. So you can, and this is our documentation so that you can, if you know how to write Python, you can kind of go through our API and use our API to do programmatic things. So this is helpful for, if you want to extend how Monolith works, you can write your own code or write your own integrations with other services to do different things. We also have, this is an example, Joaquin Metz. He's a forensic analyst that I think out of Australia. And he's just done a ton of work over the years writing this incredible set of Python libraries. And what's incredible about this stuff is that you can effectively take this stuff and write your own parsing engine for Mac OS or Windows. So you can take these basic libraries. So for an example, this libewf Python library, this is an EO1 parsing library that you can use in Python. So if you wanted to read data out of an EO1 file, you can use a library like this in Python to do that. Okay, we have a Q&A here. Good question. How would you utilize these tools for DF and investigation without contaminating evidence? Well, how you would use these tools ideally, you would run these against forensic images. If you wrote your own script, you would run these against forensic images that you collected or data that you've extracted from forensic images. So ideally, unless you're in an incident response type environment where you're working like a live breach or live ransomware case, these are tools that you should never be running against live evidence. So as long as you're running this stuff against, forensic images and extracted data, you should be fine. It's also one of those things where technically when you write this stuff, you're the one writing the code. So contaminating the evidence is only going to happen if you write your code in such a way that it will make changes to your evidence. That's what's so great about writing your own tools, is that the code gives you that control where you get to flip that switch. If you say, I want this code to alter a timestamp, or I want this code to change this file, you have to tell the code to do that. It's not going to do that on its own. But ideally, as you're learning to write these scripts, or if you write a new script, you really only want to run this stuff against data that you're not worried about it being contaminated, you're not worried about it being changed, that sort of thing. And this gets into a whole separate topic of, kind of what does it mean to validate tools? What does it mean to validate software? All that sort of thing. There's a whole kind of topic of discussion related to that. But in this case, it would be, you just have to make sure you're running this stuff against data that you're not concerned about contaminating. Another Q&A, have you written any Python scripts to complement your X-Ways examinations? If so, can you give an example, high level? Yes. So I'll tell you honestly, what I end up writing a lot of Python scripts for is not necessarily for parsing artifacts, but I use it to aid in more data analysis. So for example, if I'm looking at web history, or if I'm looking at text messages, or if I'm looking at some data set where I'm trying to get some kind of correlation, or I'm trying to aggregate the data in a certain way that helps me report on it or helps me get some insights to it, that's what I generally use Python for. Is I'll usually take Python to grab data from a text message database and kind of reorganize it and then spit it back out into a custom database that allows me to do different things. So for example, imagine if I wanted to run, if I want to do some kind of complex word search and tagging analysis on, let's say, a text message database that has 150,000 text messages in it. That's something that's really hard to do today in current forensic tools, and even really hard to do in e-discovery platforms. So what I end up using Python for is I just write my own sort of searching and tagging solutions a lot, whether that be with web history or just file system analysis, or even like text message or email analysis. I'll use Python for that sort of thing. So X-Ways is really great at like kind of letting me look at the raw data, but X-Ways is not, X-Ways doesn't have a whole lot of sort of what I would say, second order analysis features, things that let me say, okay, great, here's the data. I can see that we have 100,000 web history records. That's great. But now I need a faster way to kind of go through those 100,000 records. How can I do that? And you can write some Python scripts to do that. I don't have any specific ones that I run because they're usually different every time. Because it's usually, sometimes an attorney may ask for a certain type of analysis, and I just bang out a script to do that. The point is, once you get good at Python, once you get good at writing scripts, a lot of times, you can spend, it maybe only takes you 30 minutes to write out a script to do the things that you need to do. And then you just kind of move on to the next one. I do have some scripting resources I'm going to share here in a second, though, to kind of illustrate that. So for example, just to wrap this up, this Joaquin Metz, his set of libraries here are fantastic. So if you ever get a chance to write some Python, I highly recommend looking into his stuff. There's also a, and this is GitHub. I'm showing you some stuff on GitHub right now, which is where you're going to find a lot of this open source stuff. There's a library called MacAPT on GitHub. And this is honestly a fantastic utility. It's free, it's open source. And what this effectively does is you can point this at a Mac OS image in various formats, and it will parse out all these different artifacts for you and stick them into a SQLite database that you can then use for analysis or review. And it's really, really, really good. I mean, this is really good stuff. This is the type of open source stuff that's very impressive. And I don't see anybody talking about this library anywhere. I've used it myself a handful of times, and it's fantastic. And especially for someone like me, I like looking at raw data. I don't necessarily need something like Axiom to make the data look pretty for me or anything. So I'm happy to just have something like this that parses out the. This is sort of like log to timeline for Mac OS, kind of, but in a little bit more review-friendly way. So I highly recommend looking at this, and it's also a good example to look at when you're learning to write code. You can look at, since it's open source, you can actually dig into his code and see how he wrote certain things and see how he, put his Python together and how he wrote it. So highly recommend looking at that library. This is another app that a friend of mine, Charlie Rubisoff, wrote. This is something he calls Fetch. And Charlie is, he works at the Mississippi AG's office. And this is just a tool that he wrote because he wanted, he's had trouble with this type of analysis before himself, where basically what Fetch does is it takes geolocation data or cell tower data, that sort of thing, and it gives you a utility to map things on. This is a free utility that he provides. So you can just go to the repo here and you can actually pull it up on the web app if you want. And basically you just load in geolocation data or cell tower data or whatever it is. I'm not really a big expert on this stuff, so I don't know all the ins and outs of it, but he's demonstrated it for me, and it seems to be, people seem to like it. And it does various things like heat maps and all kinds of crazy stuff. But this is, Charlie is a guy, I've known him for years. I knew him before he knew how to write code, and I know him now that he knows how to write code. And this is stuff that he did on his own. Right? He got a few pointers from me, but by and large, he, was like, there's something cool I want to build. And he basically taught himself. He used all these different resources I just told you guys about, and he built this really cool system that offers a free way to kind of map and look at geolocation data and see different, see all this stuff where you can do cell tower analysis. You can do all kinds of crazy stuff with this. It's very cool. I also have on our GitHub repo this right here. This is an example of some SQL scripts that I've put together for various things. So just to give you an idea of, for example, when I'm ever looking at web history, if I don't want to use Axiom or some kind of parsing tool to look at this stuff, I just have some pre-made SQLite scripts that I use. So for example, this is a script just to parse download history from a Chrome database. So what's good about Chrome is that Chrome, the web browser, is built on what's called Chromium, which is just a web browser backend. And nowadays, most browsers are, sort of, I wouldn't say most, but when you look at Microsoft Edge and Chrome on both Mac OS and Windows, they're both using the same backend. So all the files and data is structured the same way. So something like this Chrome downloads script will work both for Chrome and Edge. And then for stuff like Firefox and Safari, you kind of have to write your own scripts for these. But that's okay. It's not a big deal. It's all more or less the same. You just modify it a little bit for each different browser because they're all storing their data in SQLite databases. So this is for the downloads folder, and this just parses out all the downloads, and it parses the time value, so we get sort of a human readable timestamp instead of that Chromium timestamp. Same here with web history. This is a basic script to parse out the web history records from a SQLite database. So if you have access to, if you can download and install this software here, it's DB Browser for SQLite. this will give you, this is basically a raw SQLite browser. So you can open up a Chrome history file in SQLite and then write these scripts to parse the various records in a Chrome database. I also even have this script here, which I haven't run this in a while. It should still be good, but this is a script that parses out text message data from an iOS SMS database. And what this does is it just takes all the messages and all the chats and everything, and it puts it into just a flat spreadsheet format. It includes like the list of attachments and all that stuff and who they're talking to. And this is just, I mean, this will run in seconds. If you just export that SMS DB, open it up in DB browser, and then run this script, it just quickly and easily gets you a spreadsheet of all the chat messages and who they're with including times and dates, MIME types, attachment data, all kinds of really cool stuff. So considering like if you have a case where you're just interested in text messages, you don't have to pull up Axiom or Cellbrite or anything. You can just extract that SMS DB, run the script, and like within seconds, you have the entire list of messages from that phone. And what's great about this is just this just takes a little bit of effort. Obviously, I'm familiar with SQLite, so this probably took me 30 minutes to write, but now this is a script that I have forever, and I can run it whenever I want. I don't have to rely on any tools for this. I can just do this anytime I want. Here's an example of parsing web history from a Safari browser. You can tell it's a little bit different from the Chrome history, but it's more or less same concept, right? Once you've written one of these scripts once, you can do it pretty much for anything. And then I've even got like a signal DB parser here that I've written where I guess I had a case at some point where I wrote a SQL script for signal messages out of a signal database and was able to parse it here. So this is still, even though this is SQL code, this is still something I consider programming. This is still a coding and programming concept that still applies. So it's sort of like, if you know Python and SQL, then that's a pretty powerful combination to know for just doing basic stuff like this. And if you'll notice, the biggest thing for me with this is it kind of separates your dependence on these sort of vendor-based off-the-shelf forensic tools. It gives you a way where you can do your own analysis and you don't have to worry about having, $1 billion worth of forensic software to do this stuff. And that's pretty much it that's all I have for like kind of free stuff. If you want links to this, you can just look us up, Monolith Forensics on GitHub, and this is a public list of SQL scripts, so you can just download these whenever you want. Let me see if I can just post this into the chat here. I just posted the link to it in the chat, so if you want access to this, just go to it. It's free to download. Feel free to use it. And what I'm going to round out the presentation here, I'm going to spend a couple of minutes talking about coding and using AI. So someone in the chat already kind of mentioned ChatGPT. And ChatGPT is an incredible resource for coding. But like somebody already mentioned, ChatGPT can be a little, I wouldn't say dangerous, but it can be kind of misleading sometimes because depending on what you ask it to do, ChatGPT has a habit of what we call hallucination, which means it can sometimes just make something up and tell you that it's an answer. So you have to, ChatGPT is one of those things where you kind of need to learn how to code first before you start using it, because you need to be able to figure out, you need to be able to basically discern when ChatGPT is kind of making stuff up and when it's not. So an example here that I've got pulled up is I just simply asked it, hey, how do I parse a link file with Python? And sometimes it gives you multiple options, but basically it'll spit out actual code that sometimes you can just copy and paste into your code interpreter and run it and see if it works. What I've noticed that ChatGPT will do in these situations where it screws up is it will make up libraries that don't exist. You'll ask it like, hey, how do I parse this so-and-so file using Python? And it'll be like, great, just use this file, this pre-made file parser library to do it. And then you realize that library doesn't exist and that ChatGPT just kind of made it up on the fly. But having said that, if it's a fairly common thing that you're asking it to do, its hit rate is like close to 100%. So this is an incredibly useful tool to use. Once you start getting familiar with writing code and understanding it better, and you can sort of fact check what ChatGPT gives you, this can be a very powerful tool because it can just speed up the code writing process, where it can kind of handle a lot of the boilerplate code for you without you having to spend 30 minutes figuring it out. So it's very, very powerful. The other thing I want to bring up too is once you get really advanced into coding and you really understand how to write scripts and code at a complex level, and you really want to do some interesting stuff, there are now, AI is getting to the point now where there's a lot of open source related utilities. So you can actually start writing code that implements that takes advantage of some of these large language model large language model utilities that are out there now. So for example, Facebook has Llama 3 now, which is an open source large language model, and you can literally just download it and start using it in code. So if you wanted to write your own AI chatbot, you can do that from scratch. If you wanted to use an LLM to help you parse or go through a lot of data, you can write something like that. And there's a couple of utilities that are really, really useful for sort of starting to get into writing code using AI. And one is this website called Hugging Face. It's kind of a neat, funny name, but this is a very serious company. But basically what Hugging Face is, it's a compilation of all these different AI models that you can test against, that you can write. You can basically implement a lot of different AI tools, a lot of different AI models into your code base. It's really cool. They have some playgrounds here that you can play around with, but it's a great place to kind of just start learning like all the different machine learning models, all the different AI models that you can take advantage of. Another resource is something that's called Ollama. And what Ollama is sort of a runtime engine that lets you run these large language models locally on your machine. So if you have Windows or Mac OS, you can download Ollama and then pick whatever models you want to run. I highly recommend starting with something like Llama 3. Llama 3 is just a good general high complexity foundational model that you can run locally. And what Ollama does is it just installs an executable on your system and it runs these models locally that you can then interface using an API. So that will let you write a Python script that will allow you to interface with something like Llama 3 locally and do whatever you want. So imagine you're in law enforcement and you have some data that you have an idea of, hey, I've got all this data and I want to use AI to help me. I want to use a large language model to help me kind of look at some of this information or go through some of this data. But you don't want to use something like OpenAI or ChatGPT because you then have to send all this information or data off to that third party. Well, by using something like Ollama, you can just run this locally on your forensic workstation and then start writing Python scripts around to utilize it. That way the data stays there in your lab, doesn't go anywhere, and you get the same utility of a large language model using something like Ollama. So this is something that's really, really cool. This is a fairly new product, and this is open source and free. So you don't have to pay for this for Ollama. It's something I highly encourage. Once you get into coding, you understand kind of how to write scripting and using Python and things like that. This is a very great next step to get into, where you can do some really cool stuff with this and using data. So that pretty much covers what I wanted to talk about today. Hopefully you guys got something out of this. I mean, I didn't do a PowerPoint because I think PowerPoints are kind of boring, but by doing this, you can see all these different resources that I've linked to in this presentation, just all these different Chrome tabs that kind of just shows you different places that you can go online to kind of build these resources. But having said that there, I'll wrap it up there and I'll leave a few minutes for anybody that has any questions or anything that they want to talk about or anything at all. What I'm going to do is I'm just going to start pasting some of these into the chat just so that they're there. Some of these are pretty easy to remember. I mean, Hugging Face is pretty easy to remember, but please, any other questions, please let me know. Happy to answer while I'm here for the next couple of minutes. Okay. Justin Tolman recommended Wing IDE as another good debugger, as an optional against VS Code. Replit, someone else is also recommending Replit as a code editor. It looks like we've exhausted everybody's questions. I'll give it just another minute just to see if anybody's typing up a question now. Okay. All right. Looks like nobody has any questions. So we'll wrap it up there. And thanks everybody for joining. If you're watching this as a recording, if you like what we talked about here, please check out our website at monolithforensics.com. If Monolith looks like something that could be useful for your org or your team, just sign up for a trial or reach out to us, and we'll be happy to set you up. But with that, I guess we can end the webinar now if you want to, Megan.